We present our work on expressive gesture generation through database matching. Our objective is to automatically produce gesture motion, based only on speech audio. We draw from previous research that showed how certain gesture descriptors can be predicted from the speech signal, as well as having a perceptual impact on how well the gesture matches the speech. The 5 proposed gesture parameters are velocity, initial acceleration, gesture size, arm swivel, and hand opening. Briefly, our method of gesture generation consists of 4 steps. Determining appropriate gesture timing from speech. Estimating desired gesture characteristics from speech. Selecting appropriate gestures from the database. And combining the selected gestures into a coherent animation sequence. To build our gesture database, we use over 10 hours of motion captured data, stemming from 2 multimodal datasets of speech and gesture, of 1 speaker each. The 2 datasets represent 2 distinctly different gesture styles, as illustrated here. Dataset A has not been released until now, and contains 6 hours of high-quality motion capture and speech recordings. To our knowledge, this will be the largest released dataset of synchronized motion capture and speech recordings, an important contribution to the development of future gesture generation systems. The motion data is segmented by extracting individual stroke phases, which represents the expressive phase of a gesture, carrying the emphasis and meaning. We compute each stroke's gesture parameters. The stroke data, together with its parameter values, create a gesture entry in the database. To determine when to generate a gesture, we determine the peaks of the pitch contour. A detected pitch peak marks a desired gesture peak. Around each desired gesture peak, we define a gesture slot, to be filled later with an appropriate gesture from the database. Given a gesture timing, we take the associated speech segment, and estimate appropriate gesture parameters. Given this set of desired parameters, we search the gesture database for the best match. The matching gesture is then inserted into the gesture sequence. The gestures in the sequence are connected by generating synthetic motion transitions. We evaluate the performance of our gesture generation method with 2 perceptual studies. In the first study, we compare our method to randomized gestures as well as to the ground truth. Our method outperformed random gesture selection. In our second study, we compare our method to state-of-the-art machine learning models, specifically the 5 entries of the recent Genia Gesture Generation Challenge. As an upper bound, we also include ground truth motion capture, ground truth gestures with synthetic transitions, and mismatched motion capture. Our method showed competitive performance to the pure machine learning methods. Our method may be easier to integrate into existing state-based frameworks used by game developers. We now show 4 examples of gesture motion generated with our method, 2 clips for each of the 2 speakers.
All different stuff in relation to animals like cows, chickens, horses, all that sort of stuff, because they all had that down there in the place. And obviously because it's such a kind of a scenic type of place. I mean, it's absolutely gorgeous down there, especially when the weather's good. I mean, it's just I never put anything on my skin again, but I think it was going away naturally anyway. I just wanted a quick fix. And then when that happened, my skin just kind of cleared up, kind of toward the end of college, I think it was, when my skin was kind of
made me and all that kind of thing. So he's saying like, it's a good way of nurturing people into the thing. So like, there was a huge problem with that. And like, you can see why he was trying to make that case, like for himself, but like, yeah, it's not reality where I'm constantly wanting to be somewhere else. And like, that's what I was scared of, because I was like, the classes aren't that fun. I hate the way that we wake up in the morning.
Thank you for watching.